with you.
All right, I shared the screen. You should see something, the Miro board on your own screen. Okay, yeah, you should have this worksheet from last week. Devon has already done quite a few questions. Now, we've gone through question 1, question 2 last week. Okay, so I want you to do question 3, the two of you. Question 4. All right, question 5, we've kind of gone through last week. Can you do questions 6 and 7 as well, even though 7 is quite difficult? And Devon, have you done number 8 and 9? No. Okay, can you try them out? 8, 9, and 10, and 11. I think there's one 11, right? Okay, so yep, for the two of you at home, I want you to work on all the remaining questions in the MCQ section. Now, of course, if you're not sure of anything, you can always ask. Reminder.
Sure, Mr. Chen.
For forces, there's only one big formula to remember, and this is the one. And I believe I said it many times.
T equals V
before you
minus
use
U
this
over
formula,
something.
check that you are using the F net for the F here. If it's not an F net, this formula doesn't work. Okay, yep, guys. Yeah, that's all. Only one single formula to remember. Make sure your units are correct. Quick reminder, even though I've done this for day one just now. Pause. Make sure your units are Newton, mass, kg, acceleration, meter per second squared. Yeah, just look out for this, and then you shouldn't have a problem. I mean, of course, the problem is in the interpretation. How do you apply this formula? Okay, so yeah, guys, I want you to work out the rest of the questions in your worksheet. Of course, any questions, please voice out now. No? Okay. Yep, can you work out all the remainder starting from question 3? Meanwhile, let me check day one's answers. The rest, no problem. As in, anything in particular that you can't understand?
Like they're like opposite directions, so I'm confused.
Okay, let's look at this. Yeah. This one is really this equals that. Meaning, what does that mean? That means F net is yeah, and that also means acceleration is 0.
The correct something.
But-
No.
But can something still move at 0 acceleration? Can, right? That's the trick. So when it's still moving, acceleration is 0. What does that mean? It's moving at okay, come. Maybe I answer for the rest of you. Now, okay, guys, can you highlight question 4? Question 4 is a very, very standard question, and you're supposed to get full marks for it. Now, the trick here is F equals to R. And that means F net equals to 0. There's no net force. And remember the formula I told you guys just now? If this is 0, that also implies acceleration is 0. But it is still moving forward. How can that be possible? The only possibility is moving forward at constant velocity. Okay, so take note. I can't emphasize this more than enough. If acceleration is 0, something can still be moving. Just note that it's moving at constant velocity. That is the key, and that is always a giveaway question. Make sure you get the mark for this one. All right, Damon. So, we are, of course, answer is C. All right, meanwhile, the two of you guys at home continue working on the other questions. Okay, you know the acceleration. Immediately we can have the formula. All right, so can you solve for F? Okay, no, acceleration is 6. A is 6. All right, what's the mass? 6 also, right? Okay, find what's F. So F is the F net. But here you have two forces, no? So what's the F net? No, look at the question carefully. Is moving against a friction force F. So what direction is it moving? Yeah, left to right, huh? Okay, so this is the net direction, right? And of course, that means the net force must be the same direction as well. But what's the net force then? Oh. Oh. Right? 6 and 6, right? Okay, but what's the F net? Another way to write the F net is also equal to this F net. So this is the force from left to right. This is the opposite force. Alright, so now what this is, you start into here and you find out what this is. You can, I think that's how you work on it. This one is very standard for you. Let's show you this again. Same thing, the two of you, if you have any questions, voice out. But I would really want you to try out first. This is a microphone. Easier for them to. Okay. Yep, Divan, any other question? No, the rest are fine. Okay, you carry on finishing the rest first. As I said, question 7 is quite difficult, but you just have to think clearly about it. Okay, guys, I repeat, I was telling Devon just now, look out for words like this, constant speed. And in case you have forgotten, both of you guys at home, constant speed means zero acceleration. And of course, if you remember your formula, the same old formula. Zero acceleration means net force is zero. Make sure you always recognize that. Okay, yeah, but of course you need to interpret the question and think about which is the best answer. Okay, F net is zero. There's no net force. Yep, Deepa, you must tell me what's the answer for 6. Yeah. Okay, good. Right, for the 2 guys at home, hopefully you have selected B as your answer. These are giveaway questions. You really must get them out to them. Yeah, carry on with the rest. I really need you guys to think through. Quick reminder about question 8. This is kinematics, speed against time. I just want to remind you guys, if you see speed against time, the gradient is acceleration. Okay, yes, from there, then you work further, get your answer. But at the least, you have to remember your basic kinematics. Yep, guys, for question 9, you see the same phrase again, constant speed. Okay, but now I hope you get the idea. I reckon I'll give you about what, 10 to 15 minutes to finish up. Done.
I'm not sure about question 8.
Number 8. Okay. Okay, anyway, for the guys at home, day one is asking about question 8. Let's take a look. First thing first, guys, remember your basic kinematics. This is a straight line. Day one, what does straight line mean for this case?
Accelerating.
Is acceleration is
Positive.
okay, yes. In this case, it's positive, but also it is a
Straight line. Constant speed.
constant.
Constant acceleration.
Yes, good. So it's positive. The gradient is positive, and constant acceleration. So it's not deceleration, correct? Make sure you get that correct. Now, resultant force is from 6 Newton. What is the mass? Now, guys, I told you before, there's only one single formula to use. Acceleration, yeah, you found out from the graph. Or you are supposed to find out something, right? Now, try to interpret these words correctly. Resultant force is the same as net force. So F net is 0.6 newtons. Okay, acceleration. Remember your kinematics. Okay, look at your graph. Determine the acceleration. of course, since here, Fujin, if you have any questions, also to voice out. Huh? Still okay? The rest okay? All done. Great, great. Jean, are you finished? Okay, I don't know where they are. Okay, anyway, let's just go through. Right, paper, look at number 3. Fujin and Jingqie, I'm going through right now. Right, anyway, this is all recorded, so in case you need to review it, it will be shown in the video clip. Oh, that aside, David, I need to check with you. Have you settled your Telegram issue?
No, my app store it has password. I don't know how. I forgot the password and I can't change it. That's why I can't download Telegram.
Oh, Jen, what okay, let me see. Any solution?
I think my dad can figure it out, but he doesn't have time. I'll ask him today if he can.
Yeah, if you can, I mean, it's better because I put quite a lot of stuff on the group chat. Okay, anyway, back to number 3. Yeah, what's the answer?
I got B.
B for boy.
Yeah.
Okay, good. Jingqie, I'm going through the answers now. Are you finished, Jingqie?
The MCQ, right?
Yeah.
Yeah, okay.
Okay, great. All right. I'm going through now, Fujin. I can't see you, so I don't know where you are. I didn't hear from you either. But like I say, this session is recorded. Okay, let's go on. So number 3 is B for boy. Okay, number 4. Yep, I told you guys the answer just now. C for cat. Okay, number 5. Number 5, I gone through it partially last week. They want what answer do you put for number 5?
B.
B for boy.
Oh, okay.
Yep. Okay, look at number 5. Now, this one is a bit tricky because last week I already said there are only 2 extreme possibilities. 0 degrees is here. So if that's 0 degrees, meaning that both are in the same direction, then the net force is add them together. 3 plus 4 is 7. And there's the max. But the other extreme is 90 degrees. So in other words, one is here, one force is this direction, the other force is perpendicular. And then if you use a Pythagoras theorem, everyone still remember, right? Then you should get your net force of 5 newtons. So what does that mean? Now, guys, try to interpret that. It means that your net force is between 5 and 7 newtons. Okay, so this would be your minimum. This would be your maximum. So let me put in the inequality sign there as well. So the only value that's out of this range is 4. And 4 is outside 5 to 7. Now let's go on. Okay, number 6. Yep, we have done it just now. Answer is E for boy. Okay, guys, I want you to pay attention to 7 because 7 is a difficult one. It's a bit counterintuitive, but try to follow. In which direction is the force of friction exerted by the road on the tire? This one I need to ask Jing Qian. Jing Qian, number 7.
Is it B?
Yeah, Jing Qian, I didn't hear your answer.
Is it B?
Let's take a look. Answer is E for dot. Okay, this one I need to go through. Now look carefully. Accelerating in the direction shown. Okay, so obviously it's moving from right to left. Okay, right to left. This is the difficult part. I hope you have some knowledge of cars. I mean, you should have. So in this case, the wheel is turning this way. Jing pay attention because this one has a high chance of coming up winning. Okay, the wheel is turning clockwise. Oh, sorry, anti-clockwise. And the tricky part is this, since it's turning anti-clockwise. Look at the interface here. This, let me bring in. All right, so therefore, the tire is rubbing against the road, and therefore, your friction is in the opposite direction on the tire. All right, because it is opposite to movement of the tire. Okay, so this is the tricky part. Yeah, as I said, Jing, make sure you get this because it really has a high chance of coming up for you. Questions, anyone? Jing, okay. Steven, yeah, let's go on. Okay, number 8. I think I more or less told you the answer just now. Jing, what's your answer for number 8?
I put D.
Yeah, Jing, number 8.
D.
B. Okay, I can't remember. So let's take a look. Guys, Steven, you get it right? You did. Okay, great. Now make sure you can calculate the acceleration. Remember this formula. Okay, look at this point, number 9, 9. Look at this point, 0. So initial speed is 0, and the time 3 seconds. Okay, so that will give you 3 meters per second squared. And that, of course, is subject. You did this right, David? So let's go on. Okay, number 9, as I said, moves vertically at constant speed. Vertically upwards, constant speed. So immediately you know that P and R are the same. Constant speed means 0 acceleration. Okay, David, you figured it out? You did, huh? Okay, what else? Look carefully. It's moving vertically only, no? Is it moving horizontally to the left? To the right? No, huh? So immediately, that also implies S equals to Q. Okay, I hope everybody managed to figure that out. So answer, David?
D.
D for dog. Yeah, okay, good. All right, make sure you get that. If you can't, please voice up because I can't really see the two of you back at home. Let's go on. Number 10. Forces acting on the rocket. Jingqian, number 10.
C.
Yep, good. Make sure you get C. It's moving upwards, so air resistance must be opposite, downwards. Okay, let's go on. Okay, 11. Find the acceleration. Yep, Jingqian, number 11.
C.
Okay, it should be A. Do you get A? No. All right, let's go through quickly. 50 kg is the mass. Pushing force is 340. Friction is 320. Guys, I emphasize there's only one formula. But you have to figure out what's the F net, no? All right, so in this case, the box is like that. You push it 340 newtons. But don't forget there's friction. Friction is always opposite. 320. Okay, so what's the net force? Oh, guys, you have to know this. So net force is 340 minus 320.
20.
Yes, 20. And of course, in this case, it's to the right, based on my diagram. Okay, so in this case, sub-inch 15 newtons. All right, sub-inch 15 for mass. And you should be able to find what is your acceleration, no? You should. Okay, so yeah, make sure you don't get that wrong. They want you to.
I used the wrong formula.
What formula do
I
you
used acceleration.
mean this one?
Yeah.
But they give you force, right? Yeah, guys, yeah, just have to read carefully.
But I got the force, like the 340 minus 370. That part I got.
Yeah, but you still have to get the remainder correct. Okay, yeah, guys, I think these are basic questions I have to remind everyone. Okay, I have printed out something for you guys, but then you are not here, so I pass it to Devan first. I'll send you the soft copy, so you guys hang on. Alright, Jing you hang on, or Fujin as well. I'll send you the soft copy in a moment's time. Okay, yep, they know this are open-ended. Find out everything. Fujin, hang on, let me prepare the soft copy now.
Okay, yeah,你看你就来嘛，这几个这个，我们看你用的，这个公安卡证呢，公费呢，在这个考试，还是从北方帮到，或者这个考试把帮到什么样子，有爱，都total and of the year.
Okay, for the two of you at home, I'm going to send it to you via Telegram.
The mass of the page and the mass of the page and box is 20% of the total mass of the year. Okay, so it's alright.
Okay, Fujin, Jing, check your Telegram.
Sometimes they find the total mass on here. So the thing done to you. Then total mass is here. Then the time you want to find a trade, you also got the figure. Also got. We'll take this 20% time. This total mass. Then run about 10 together. This will be the total mass. Okay, try something. Find the total mass of the figure, the 50 pound, 30%. You take option one box to the figure, 20 pound, 30%.
Hello, Xingxuan. Oh, that's not Xingxuan.
Not sure. Blue.
Not sure. Oh, okay. Give me a moment. Okay, same thing, Cynthia or Fortune. If you're still there, any problems, let me know. Okay, anyone? Look at the screen. Again, you just have to interpret the question. Alright, for the part one, you just use the same formula again. Alright, average accelerating force. Now, in this case, the accelerating force refers to F net that you have to interpret. M, yes, you're given M. Okay. A, oh, you're given here too. Alright, I hope you get that. Alright. Is it okay? Okay, same thing for you, Jingjie. If you have problems, questions, or you're done, let me know as well. Okay, for part B, it's asked about the speed. Well, F equals to MA has no speed inside, so you have to use your kinematics formula for the speed. Right, so look up for all these things. Speed is only present in the kinematics formula for acceleration. About C, now C, you have to interpret it correctly, though, because if you look at the question again, what does it say? Accelerates along the runway. So this one accelerates along the runway. So this is horizontal movement. Okay, but look at this question. It's asking you about the vertical movement. All right, so whatever is given in the question is not applicable. So what's the vertical force for takeoff? And in fact, they add in the word minimum. So how do you interpret that? All right, so basically, you have to overcome the weight. That takeoff force has to overcome the weight of the aeroplane. So your job is to calculate what is the weight of the aeroplane. Remember the formula? Devon, just now I mentioned the weight formula, right? Use that one. All right, Jingjie, I think you were not here. You were not here in the classroom. So essentially, you need to use this formula to calculate the weight of the aeroplane. All right, again, make sure you remember this. And make sure you remember the value for G. Jingjie, can you remember what's the value for G?
For what?
G.
V
G.
or G? 10.
Yes, good. Better still, remember the unit. Okay, everyone, I hope you have a better idea now. Again, guys, likewise for question 4, I've given you quite a lot of hints here. You know the mass. You know acceleration is constant. From rest means initial velocity is 0. You are also given final velocity. And you're given the time to, based on this, what should you use? You should have a good idea by now. Okay, Jingqie, just a note for this question one, this one. This one, you can keep it for homework. Right, this one, which is not in your copy, Damon.
Is it in the one you sent already?
Yeah, it is in the soft copy I sent you.
Okay.
This one you can do it for homework.
Alright.
But try to do this as well. This one is quite straightforward. No calculation. You just have to show the free body diagram. All done, Devan? Good. How about this one? Finish off this one. This one is quite easy, quite easy. You should get it right.
Point x square plus 0.
Okay, make sure you guys remember some of the forces that always act. And some of the forces, when you have like, for example, a thin thread, where is the force acting in? Yeah, these are basic stuff that you really need to know. Jingqie, are you done already? Besides the homework one,
Which one?
I mean, are you done with this one, the one on the screen right now?
Oh, no.
Oh, no.
The air resistance acts on it, right?
Okay. Yes, Jingqie, I don't know whether you heard what they want to say. Is air resistance acting on it? Air resistance only acts when something is moving. Is it moving?
No,
Is it?
they said yeah, it did move, but it's held at position X.
Yes, so that is, I would say, the not so clear part. So basically, where's the word? L in position X. Yes, no choice. You guys have to really look up for such word. It means it is stationary.
换外解析的，解析是当读书
That means it is stationary, not moving. And that also means, yep, they want make sure you understand. No air resistance.
说要做的嘞，它不是非常，非常大。
Okay, so maybe since you're at this page, we must have work on it. So Xingjian, for this case number 2, what forces are acting on the sphere?
Gravity.
Gravity, yes. Make sure you draw a straight downwards, which is the weight. What else, Xingjian?
Is there a normal force?
Is it resting on any surface?
Oh, no then.
No. Okay. Yeah.
Tension.
Yeah. Where's the tension?
There's I know the arrow going this way, that's why I know.
Okay. At least you remember that. Okay. Before I go to that, take note. 境界 2, there is no normal force, or normal reaction force, because if there is no contact with any surface. Okay, so Devan is right. But look out for this kind of things in thread or rope or spring. It implies that there's tension. And of course, in this case, tension is to balance against the weights. And it only makes sense that tension is going up along the string, along the track. Okay, they want along the track in the direction of your spring or track or spring. So if you want a very nice diagram, it should look like this. F is still there. So make sure your F is in your answer, please. Okay. Okay. Now, let me just finish up on that. Okay. Accelerating force. The one answer you have. Good. Make sure you count the correct number of zeros. Correct, right? Okay, great. Of course, since you have any questions, please ask. Next one, speed after 25 seconds. Now, as I said, speed must be calculated using this kinematics formula. Devon?
Not 0.12. Yep. Oh, wait. I got the answer in the previous question.
Oh, okay. So it's just balance, huh?
Yeah,
So no need for me to work out. Huh?
yeah.
But yes, Jingxie, I hope you get the answer. Did you? Okay. C, Devon?
I just added a 0 to
How many?
part A.
All right. No, what answer do you get for C?
360000.
Oh, that's careless of you. What is the mass? You notice the mass here?
Oh,
Did you notice this one? Okay, so guys, yeah, please read carefully. It's not about the force, but the mass. Okay, lastly, number 4. All right, number 4, Cynthia, what answer did you get?
I skipped that question.
But you skip how about you, Devon?
4950.
How many?
4950.
Okay, let's check. Oh, great, you got it. Hey, Cynthia, you got to try number 4. Don't skip it. Okay, but let me just quickly do it. Basically, you have your mass, you have your acceleration, and your speed. Yeah, basically just use your kinematics formula. And resultant force is the force of F net. And F net equals to MA. So basically, you sub your A over here. And you should get your answer. Okay, Jingqian. Don't skip it. This one is quite easy. Okay, guys. Jingqian, I want you to do that remaining question as homework. So I'll see you next week.
Okay.
Okay, yep, that's all. All right. That's all for today. Good night.
Bye.
Okay. Next one. I want you to try to it's a bit difficult. That's why I give it to him, but you can try this.
Okay. Wait, do I know this for what?
Yes, homework.